Hello student friends, myself R.D. Mahajan, Assistant Professor, Marathwada Institute of Technology, Aurangabad, presenting next video on the topic Maclaurin's Theorem. Let us see the statement of that theorem. In the previous video, I have discussed the Taylor's theorem. In that Taylor's theorem, if we put A is equals to 0 and B equals to 0 in Taylor's theorem, we get this Maclaurin series or Maclaurin theorem. F of xy is equals to f at 0, 0, means x is equals to 0, y equals to 0, plus x fx at 0, 0, y fy at 0, 0, plus 1 by 2 factorial x square into f double x at 0, 0, plus 2xy fxy at 0, 0, plus y square f double y at 0, 0. All this suffix stands for the partial derivative. Fx means dou f by dou x, fy means dou f by dou y, f double x means dou 2f by dou x square, fxy means dou 2f by dou x dou y, and f double y means dou 2f by dou y square, which already I explained in the previous video also. Is known as a Maclaurin's theorem. I will explain this by solving two simple examples once again. First one, expand e raised to x minus y using Maclaurin's theorem. Here given f of xy as e raised to x minus y. This is given. Differentiating this with respect to x, keeping y constant. Therefore, derivative of this with respect to x is e raised to x minus y. Applying chain rule, derivative of this two term with respect to x, derivative of x is 1 and derivative of y is 0, and therefore we get this one. Then differentiating with respect to y, keeping x constant, therefore its derivative is e raised to x minus y. Chain rule, derivative of this with respect to y is minus 1. Okay, then differentiating again with respect to x, we differentiate this again with respect to x, therefore its next derivative is e raised to x minus y. Once again chain rule, derivative of this term with respect to x is 1. Okay, then fxy dou 2f by dou x dou y, either differentiating this with respect to y or this with respect to x. Therefore, I will differentiate this with respect to y. Its derivative is e raised to x minus y. Chain rule, derivative of this term with respect to y is minus 1. Okay, and fyy is equals to differentiating this with respect to y. Therefore, it is minus e raised to x minus y. Differentiating these two terms with respect to y, its derivative is minus 1. Okay. Therefore, if you want, we can simplify this. It is equals to e raised to x minus y. This is minus e raised to x minus y. This is e raised to x minus y. This is minus e raised to x minus y, and this is minus minus plus e raised to x minus y. Okay, then we calculate all these values at 0, 0. At 0, 0 means x is equals to 0 and y equals to 0, and therefore if we put that we get the value of f at 0, 0 as e raised to 0 minus 0, that is e raised to 0, and e raised to 0 is 1. Then fx at 0, 0, here it is e raised to 0 minus 0, we get 0, e raised to 0 is 1. Fy at 0, 0, it is minus e raised to 0 minus 0, e raised to 0, and e raised to 0 is 1, therefore it is minus 1. F double x at 0, 0, okay, this one is e raised to 0 and e raised to 0 is 1. Fxy at 0, 0 is equals to minus e raised to 0, and that is minus 1. And last, Fyy at 0, 0 is equals to e raised to 0, and e raised to 0 is 1. Therefore, these are the values. Substituting these values in this Maclaurin theorem, we get f of xy. F of xy means that given function, it is e raised to x minus y is equals to, first term is f of 0, 0, the value of f of 0, 0 is 1, plus, in bracket, x into fx at 0, 0, the value of fx at 0, 0 is 1, plus y into fy at 0, 0, the value of fy at 0, 0 is minus 1, okay, plus 1 by 2 factorial, okay, x square f double x, the value of f double x at 0, 0 is 1, plus 2 times xy fxy, the value of fxy is minus 1, plus y square f double y at 0, 0, the value of that one is 1, and plus so on. And therefore, if you simplify it, we get the required series as 1 first term plus x minus y plus 1 by 2 factorial. 2 factorial is 1, 2, therefore 1 by 2 into x square minus 2xy and plus y square, and so on, as the required series or as the required answer. Therefore, whatever this series we are getting, that series is called as the Maclaurin series obtained by Maclaurin's theorem. Example 2, expand f of xy is equals to e raised to y into cos x, e raised to y into cos x in Maclaurin series, in Maclaurin's series. Okay. Therefore, here the given function is e raised to y into cos x. Therefore, solution given is f of xy as e raised to y into cos x, function of two independent variable x and y, which we can differentiate with respect to x, y. I'll try to get all these derivatives. Therefore, fx differentiating with respect to x by dou x, keeping y constant. Therefore, this one is constant term outside. Derivative of cos minus sin x, and therefore this one is minus e raised to y into sin x. Okay. Then fy differentiating with respect to y, keeping x constant. Therefore, cos x constant term, and derivative of e raised to y is e raised to y. Again differentiating this with respect to x, keeping y constant. Therefore, minus e raised to y constant term. Derivative of sin x is cos x. Differentiating this with respect to y, or this with respect to x. Therefore, I will differentiate this with respect to x. It is e raised to y constant. Derivative of cos x is minus sin x, and therefore it is minus e raised to y sin x. Okay, and the last fyy, once again differentiating this with respect to y, keeping x constant, cos x constant term, and derivative of e raised to y is e raised to y. Okay, and then finding this at point 0, 0. Therefore, we get f at 0, 0, substituting x and y at 0, e raised to 0 into cos 0. Cos 0, 1, e raised to 0 is 1, therefore it is 1. Fx at 0, 0, it is minus e raised to 0 into sin 0, and as sin 0 is 0, this term becomes 0. Okay, then fy at 0, 0, e raised to 0 cos 0, cos 0, 1, e raised to 0, 1, therefore that product is 1. F double x at 0, 0, minus e raised to 0 cos 0, again 1 into 1, we get 1 with this minus sign, therefore value is minus 1. Fxy at 0, 0, this one is minus e raised to 0 sin 0, and sin 0, 0, therefore this term is 0. And last fyy at 0, 0, e raised to 0 cos 0, and 1, 1, therefore that value is 1. Therefore, substituting all these values in this Maclaurin's theorem statement, and therefore we get f of xy means that e raised to y into cos x. The terms on the right hand side, f at 0, 0, the value of f at 0, 0 is 1, plus x into fx at 0, 0 is 0, therefore this term becomes 0, plus y into fy at 0, 0, fy at 0, 0 is 1, plus 1 by 2 factorial into x square f double x at 0 0 minus 1 plus 2xy fxy 0 plus y square f double y at 0 0, it is 1 plus so on. We can extend up to infinity. If we consider this number of terms, we get the second order series. If we add next, we get third order like this. Therefore, if we simplify it, we get 1. This one is 0. Therefore, next term is y plus 1 by 2. It is y square and minus x square. This one is 0. And plus so on. As the required Maclaurin's series. Okay. Therefore, with the help of these two examples, I have explained how we can obtain the Maclaurin's series. Important one is here the Taylor's theorem, and in that Taylor's theorem, we have to put a equals to 0 and b equals to 0 to get this series. Therefore, whatever the given function, find all these derivatives fx, fy, f double x, fxy, f double y, and then find its values at 0 0. And whatever that values, put in this to get the required series. Okay. Therefore, like this, I have completed the third unit, application of partial differentiation, in which I have explained, I have presented the videos on the topics. First one is Jacobian, second chain rule, Jg dash is equals to 1, properties of Jacobian. Third, maxima minima for function of two independent variable. Next, Lagrange's method of undetermined multiplier, and last two are Taylor's theorem and Maclaurin's theorem. Okay. Next video I will present on next unit, that is reduction formulae and curve tracing. Therefore, if you are watching my videos, please like and share it, as well as subscribe my channel for latest updates or the new videos. Thank you.